A plane carrying another plane on its back. Sounds impossible, doesn't it? But America did something even crazier. They built military aircraft that carry spacecraft, not toy models, not empty shells. Real 170,000-pound machines flying through the clouds. How is that even possible? The answer lies in engineering so bold, it rewrites what flight means. When NASA builds something too massive for any road, they make one phone call, and within hours, a flying giant arrives. These aren't ordinary cargo planes, they're beasts, designed for missions nobody else can handle. Some swallow entire rocket stages in one bite. Some carry space station modules across continents, and one of them looks so strange, people think it's fake. But here's what most people never realize. Without these aircraft, America's space program would have collapsed. Every moon mission, every shuttle launch, every Mars rover, they all depended on machines you've probably never seen. And today, you'll meet them all. Stay right here, because what comes next changes everything. The year was 1962. America was racing to the moon and losing. The Soviet Union had already sent a man to space. Now NASA had one mission, land on the moon first. But there was a problem nobody talked about. A problem that almost killed the entire program. The Saturn V rocket, the most powerful machine ever built. Its stages were manufactured across America. Florida, California, Louisiana, Alabama, each piece built in a different state. Thousands of miles apart. And here's where everything got complicated. How do you move a rocket stage the size of a building? Some stages measured over 30 feet in diameter. Some weighed more than 25 tons. Roads couldn't handle them. Bridges would collapse. Railways couldn't fit them. Tunnels were too small. Ships could carry them, but far too slow. And here's what nobody talks about. Ocean transport meant weeks of delay. Salt air corroded delicate components. Unpredictable weather threatened schedules. Engineers watched helplessly as precision instruments degraded during long sea voyages. Humidity seeped into electrical systems. Vibrations from ocean waves damaged fragile wiring. One contaminated component could delay an entire mission by months. In the space race, a single week could mean defeat. The Soviets weren't waiting. Every day lost was a day closer to Soviet victory. The solution wasn't building smaller rockets. It was building bigger aircraft. Aircraft so unusual, so enormous, they'd rewrite aviation history. And one man had a radical idea that would change everything. What if you could make a plane swallow rockets whole? Look at a Super Guppy once, and you won't believe your eyes. A body so swollen, it looks like a cartoon, like someone pumped air into a normal plane until it almost burst. People see it and laugh. But that bizarre shape hides a genius secret. Back in the 1960s, a company called Aerospace Lines did the unthinkable. They took old Boeing Stratocruisers and ripped them apart, gutted the insides, rebuilt the frame, expanded the body. What came out looked like a flying whale. But it could do something no other plane could. It could swallow rockets whole. The cargo bay stretched 25 feet wide and 111 feet long, big enough to fit an entire Saturn V rocket stage inside. Maximum payload, 51 tons of spacecraft hardware. Range, 3,200 kilometers without stopping. And here's the brilliant part. The nose swings open, like a giant mouth ready to feed. Components that could fill a gymnasium just disappeared inside. The doors closed, the engines roared, and America's moon rockets flew across the country. During the Apollo program, Super Guppies flew hundreds of critical missions. Saturn V second stages, command module components, lunar module parts. Every piece arrived pristine, ready for assembly. Ground crews worked through the night, unloading spacecraft hardware under floodlights. Technicians inspected every component before transport to assembly buildings. But wait, there's more. NASA's last Super Guppy is still flying today, 6 decades later, still carrying spacecraft parts, Orion capsules, Artemis hardware, space station modules. The strangest plane ever built, and still irreplaceable. But America didn't stop there. They built something even bolder, a plane that carries a space shuttle, sitting right on top. 170,000 pounds, perched on another plane's back. Not inside, not underneath, right on top. like a child riding on a parent's shoulders. This was NASA's most audacious idea yet. The space shuttle was a glider. It couldn't fly on its own. After landing in California, it needed to return to Florida. 122 feet long, 78-foot wingspan, no jet engines for cruising. So how do you move something that can't move itself? You carry it. NASA took the world's most iconic airliner, the Boeing 747, and turned it into a flying spacecraft transporter. Two 747s were chosen for the mission. NASA 905, a 747-100 model. NASA 911, originally built for Japan Airlines in 1973. Both planes were completely gutted. Every passenger seat removed, every luxury feature stripped away. And then the real transformation began. 3 colossal struts bolted onto the fuselage. Interior structures reinforced to handle 85 tons on the roof. Extra vertical stabilizers added to the tail for balance in flight. Special aerodynamic fairings covered the shuttle's engines. Wind tunnel tests ran for months, perfecting every angle. Everything designed for one purpose: carry the shuttle safely home. And it worked. For 30 years. The pilots who flew these missions became legends. They described flying with the shuttle as wrestling a building through the sky. Every flight required precise weather conditions. Crosswinds above 15 knots. Mission scrubbed. Turbulence forecasts checked hourly. The final ferry mission flew in September 2012. Endeavour soared over California one last time. Millions watching below. Schools released students early. Families gathered on rooftops. Traffic stopped on freeways. An entire state paused to witness history flying overhead. Then both carrier aircraft retired to museums. But the military had something even bigger already in the sky: the C-5 Galaxy, and NASA was about to transform it. The Lockheed C-5 Galaxy, a name that commands respect. America's largest military strategic airlifter, built to carry tanks, helicopters, entire military units, a flying fortress designed for war. But NASA saw something else inside this beast. They saw a spacecraft carrier waiting to be born. In the late 1980s, 2 C-5A aircraft received special orders. Tail numbers 68-0213 and 68-0216. These weren't ordinary upgrades. These planes were about to become something classified: the C-5C, Space Cargo Modified Configuration. Military muscle, transformed for space exploration. And the modifications were extreme. The entire troop compartment ripped out. Rear loading doors, redesigned for oversized cargo. The result, volumetric capacity far exceeding standard C-5s. Now this flying giant could swallow things no other plane could. Satellites, space station modules, telescope components, everything NASA needed fit perfectly inside. And the numbers are staggering. 28 wheels across 5 landing gear sets. 4 powerful General Electric turbofan engines. Payload capacity twice any other American airlifter. This plane could carry 6 armored military vehicles in one trip, or 5 full-sized helicopters. No problem. When NASA needed military-grade heavy lift, the C-5 answered. Hubble Space Telescope parts rode inside this giant. International Space Station modules crossed continents in its belly. The Chandra X-ray Observatory traveled safely within its hold. A military workhorse, serving humanity's journey to the stars. But Boeing had a completely different idea cooking. They weren't modifying anything. They were building something brand new. The Boeing 787 Dreamliner changed commercial aviation forever. Lighter, faster, more fuel efficient than anything before. But building it created a unique problem. Wings manufactured in Japan. Fuselage sections built in Italy. More parts arriving from South Carolina. Final assembly happening in Everett, Washington. Thousands of miles between each piece. So how do you connect a global supply chain fast enough to meet deadlines? Boeing had a radical answer. Take a 747-400, one of the most famous planes ever built. Gut it completely. Rip out everything inside. Then expand the fuselage until it becomes a flying warehouse. The result, the Dreamlifter, the largest cargo aircraft by volume on Earth. And the numbers are absolutely staggering. Internal capacity, 65,000 cubic feet. That's 3 times the volume of a standard 747 freighter. Maximum payload, 250,000 pounds of aircraft parts. Only 4 Dreamlifters ever built, at $250 million each. But here's the engineering magic. The entire rear section swings completely open. A swing-tail door rotates sideways, revealing a cavernous cargo hold. 787 fuselage sections slide in like shipping containers. Cruising speed, Mach 0.82. Range, 4,200 nautical miles fully loaded. Each Dreamlifter completes over 1,000 flights yearly. That's nearly 3 flights every single day. The Dreamlifter connects the world through the sky. But carrying them was only half the problem. How do engineers make these aircraft actually fly? The challenges are immense, and the answers are pure genius. Building an oversized cargo aircraft isn't just about making it bigger. Every single expansion creates new problems. Structural stress. The frame wants to tear apart. Aerodynamic drag. The air fights back harder. Center of gravity. One wrong calculation means disaster. Each challenge demands a revolutionary solution. Normal aircraft are designed for efficiency. Sleek bodies. Streamlined shapes. Optimized for speed and fuel economy. But oversized cargo aircraft sacrifice all of that. Their bulbous fuselages fight the air every second of every flight. And the engineering solutions are remarkable. Structural reinforcement adds thousands of extra pounds. Loading systems must handle cargo weighing 50+ tons. The Super Guppy and Beluga XL. Their noses swing completely open. The Dreamlifter. Its entire tail rotates sideways. The C5 Galaxy. Heavy rear ramps drop down for loading. But here's what most people never consider. When a 26-ton rocket stage slides into a Super Guppy, everything shifts. The center of gravity moves instantly. Pilots must recalculate everything. Weight distribution, fuel load, takeoff speed. One mistake, and the aircraft becomes uncontrollable. It's like flying a building that wants to tip over. One veteran pilot explained, "These crews are among the most skilled aviators alive. They train for years before touching these aircraft. Simulator sessions replicate every possible emergency. Engine failures, sudden weight shifts, extreme crosswinds. Cruising speeds drop significantly. Flight ranges shorten compared to normal planes. The aerodynamic compromises are substantial, but for NASA's cargo, there's simply no other way." Now, America wasn't the only nation solving this problem. Other countries built their own giants, and some pushed even further. The Soviet Union created the Antonov Tu-25 Maria, the heaviest aircraft ever built. 6 turbofan engines, 640-ton maximum takeoff weight, cargo capacity of 250 tons, more than anything before or since. It carried the Soviet Buran shuttle, just like NASA's 747 carried the American one. 2 superpowers, same engineering solution. When the Soviet space program collapsed, the An-225 found commercial work. Then February 2022 came. Russian forces invaded Ukraine. The An-225 sat at Hostomel Airport near Kiev. It never flew again. The greatest cargo aircraft ever built. Destroyed forever. Europe answered with the Airbus Beluga XL, a transformed A330 with 78,000 cubic feet of cargo volume. The largest operational cargo aircraft today. It looks like a whale and carries Airbus components across the continent. But for NASA missions, American aircraft remain supreme. The Super Guppy, the C5 Galaxy. These machines carry America's space dreams. No foreign alternatives needed. So why do these strange aircraft still exist today? Why hasn't modern technology replaced them? The answer reveals something profound about progress. Modern aerospace manufacturing works differently than most people think. Nothing is built in one place anymore. Rocket stages built in Alabama. Capsules assembled in Louisiana. Satellites manufactured in California. Everything launched from Florida. Thousands of miles between each piece, and each piece must arrive perfectly. Think about the James Webb Space Telescope. It took 20 years to build. Components came from NASA, from Europe, from Canada. Each piece traveled across oceans and continents. Each piece needed perfect protection during transport. Only specialized aircraft could handle that job. And here's the counterintuitive truth. Ships are cheaper, trains are simpler, but air wins every time. These are the aircraft that lift NASA spacecraft like nothing. If this video revealed machines you never knew existed, subscribe. We explore the engineering miracles that make the impossible possible. Which aircraft amazed you most? The swollen Super Guppy, the piggyback shuttle carrier, the colossal C-5 Galaxy? Drop your answer below, because these aircraft aren't just flying, they're making history.